Hey, ladies and gentlemen, let's take a look at what's going on here. Just so you guys know, we are going to be meeting in this room this week because they are converting. Let me go back and write this down. Okay. So we're going to be meeting this week. This week is going to be what? 3:06 to 3:10. And we're meeting in E3. What is this? E3 325? Okay. For this week. Now, the reason being is because they're converting the classrooms in that basement area to HyFlex classrooms. So like some of the stuff you guys see here, that's what's going on. So I hope you guys did, sounds like you guys did. Hopefully you're connected to Canvas and you get the notifications. That's why, you have Canvas on your phone so you guys can hear what's going on when it's going on so you're not out of the loop. So anyway, just to kind of let you guys know. Did not know whether we have an adequate projector here or internet service, wireless. So that's why I sent the communication this morning about it. So anyway, glad you guys are here. And then also, if we look back, we have something due today. Is that right? So something was due. Your take-home portion was due online and in Canvas. Okay. And I did send communication to you guys. Number 4, you could have changed that to 0 to x to 2 pi. It would have made it a little bit easier, but if you didn't do it, that's fine. I can tell you already, let's see, that was due 5 minutes ago. So we have about, how many people turned that in? Maybe about 14 people turned it in, 14, 15 people. Anyway, that was due. I also sent you guys an announcement this week, and I hope, what did I send? Oh, yeah. Did I send this one? Calculus 1 review. Yes. So remember, I sent a whole bunch of review for you guys. Oh, no, this is, wait a minute. It should be more than that. Is that right? There we go. Calculus 1 review, there's a whole page. Intervals of increasing, decreasing, intervals of concavity, integration by U sub, derivatives with chain rule, area between curves, volume by the disk method, volume by cylindrical shells. These are all Calculus 1 topics that in theory you guys had or covered in theory. Okay? So if you have to review, I recommend, review, because we're going to see some of that today. All right, we're going to see some of those things today. That's why I made that recommendation. So, all right, ladies and gentlemen, some of the assignment, I think I did get a question on people asking, hey, are you really going to ask for 8, 3, 51, 52? Yeah, these are some of the questions I want to go over today, by the way. Some of these types. Also a little bit of review. Okay, but they're all involving using integration by parts. So I do kind of want to mention that. So here's let's continue with integration by parts. Anybody work on this stuff this weekend by any chance? I hope. Integration by parts. Remember, you don't want to wait till the night before, because what happens then, if you do, is it ain't going to happen. So let me give you another integration by part question. A couple of them that are pretty good examples. These are all IBP. 1, 4, and you say, okay, what about something like this? E to the x dx. All right. Let's see if I get my coffee. Coffee. So let's wake up with this one. So ladies and gentlemen, believe it or not, this is an 8.1. And in 8.1, what do you guys study in that section? Integration by what? Parts. All right, integration by parts. So what do you think the technique's going to have to be here to do integration by parts? Right? Are you going to try to do something a bit different, right? You probably shouldn't. You should probably stick with IBP. Now, does anybody know, I mean, how do you handle this kind of question? Right? Yeah, so integration by parts, let's write down that formula. So it's integral of u what? dv equals uv minus integral v du. And, you know, we had a great question last week, which is, it's kind of a good question. How do you know when to use integration by parts? How do you know not to use integration by parts, right? That's not a simple question to answer. Generally speaking, you use integration by parts when you have a product of two functions. Okay? And you say, okay, I don't see two functions, I only see one. Why are they doing this? And remember, when you have a product of two functions, hopefully one function differentiates easily, meaning you break it down in terms of its power by differentiating. Doesn't always happen though. So what I'm saying is you do want to try these out, and you want to try this and cry, kick, and scream. You can't go to I don't know how to put this. You can't just look at this and say, oh, I just have a format that always tells me what to do because I don't want to think. Some people do that. They don't want to think. They just say, just tell me what to do, when to do it. And like, well, you can't. This is an IBP. The idea for you is to try to integrate this by IBP. Now, remember, we've seen when it's only one function, what do you guys want to do when it's only one function, right? This function, when there's only one, this has to be your what? Your u. Okay? Because there's only one function. And so now u is going to be what? The square root of x. Then what does that mean by default this has to be? This has to be your what? dv. Okay? Because you can't let u be dx. When you have to differentiate it, it doesn't make any sense. So then this is going to be our dv equals our what? dx. Okay? You guys okay with that? Anybody have any questions here with how you start this? This is your u, and then this is your what? It's e to the square root of x. Yeah, and in fact, there's another way to kind of do this, but I just want to kind of, I don't even have, I just have, when I have in my notes is problems to work on. I don't have solutions. Like I put here in my notes, okay, work on this problem, this problem, this problem, this problem. I checked, right? So I'm going to tell you guys, I know I do have a way to do this one that's a little bit different, but it requires u sub. But let's see how this works, right? I'm going to say this. What is this derivative? Do you guys know the derivative of the square root of x? It's 1 over 2 what? Square root of x. Is that true? All right. And so you might say, why do I actually have to find this? Because you're really trying to get du. Is that right? What that means is du will be, multiply both sides by dx, that's dx over 2 square root of x. And then here, if you have dv is dx, that means v is the integral of what? dx, which means v is just going to be what? X. Okay? And so now you're going to use this integration by parts portion. This is what I mean. You're going to use this right side. And on the right side, you say, okay, I need uv. Okay, that's x square root of x minus v, that's x, and I need du. You say, what is du? Well, it's dx over 2 what? Square root of x. Is that right? You guys okay with this? Double check, because I'm not really awake. Yes? Oh, I'm sorry. Thank you. I told you I'm not really awake. I'm not really awake. Let me go back. Apologize. Thank you. Thought this is too easy. I'm glad you're awake. Let's do this here. U is not the square root of, well, I can do it that way. I can do it that. In my notes, I have a way to do this. But I'm going to go with this, okay? All right. Thank you. So now you say du dx is e square root of x. This is the chain portion. This is why I said to you guys, review that, right? This is the chain portion. So du dx is going to be e squared of x times 1 over 2 squared of x. Okay? So then now you have your du is e squared of x times 1 over 2 squared of x dx. Okay. Thank you. So this is probably something that students might approach. This question is why I want to do it this way. Because you say, I'm going to approach it this way. This is the instructions we got last week. Okay. See what happens. Now you say, okay, what happens here? uv. And there we go. So uv now here, we're going to say now what? X e what? Square root of x minus integral of v x. And then you say, well, what is du now? Du is e square root of x over 2 square root of x, what? Dx. Get x e squared of x minus now 1/2. And what happens right here with this? Do you guys know what happens? With the x and the square root of x? What happens algebraically? That's now square root of x, what? E squared of x. So double check to see if that's what's going on here. All right, double check. Am I okay with that algebra? X over the square root of x, is that square root of x? Okay. And so keep in mind, this is just the integral of e what? Square root of x dx. So then the question's going to be now, what happens with this integral here in green? Huh? Yeah, what happens here, you might say, I'm going to have to use what again? Integration by parts. But now, what do you think u is? Because I'm just approaching it as a student would, right? What would you do now? What would u be? What do you guys want to try u to be? The function that breaks down when you differentiate it. And so I'm going to try this, okay? You guys with me on that? I don't know. I know how to do it by another method, but what is u? Square root of x. And then what do you think this will be? Yeah, I'm going to try to change some colors here, I guess. So this is going to, oh, no. So this highlight here is going to be what? That's my dv. Oops. Okay? So then du dx is again 1 over 2 square root of x. Is that right? And then what is v here? It's the integral of e square root of x dx? Uh-oh. Is that true? And then, what would you do here? Well, I don't know. Does this kind of double check? Am I like not awake yet because I didn't have sleep and then we got a different room? I haven't even finished my coffee because I've been running around this morning. Anybody see a problem? No? Just double check. Am I in the right place right here? Is that true? Remember, this is my u, and this whole thing's dv. Is it true? So dv is this e square root of x, which means v is the integral. What's my point? I'm right back where I started. Isn't that the original integral? This is the original integral. That's your original integral. So as a student, you would look at this and you'd say, oh, wow, what do I do now? I'm back to the original integral. And this is in my integration by parts homework. Yes? Well, I'm going to go with some recommendations here, right? Double check. Daniel is making a recommendation here. He says, you divided by the square root of x. Did I do something wrong? Does anybody see a typo here that I did wrong? Anybody see a mistake? I think I'm okay, but no guarantee. All right, well, what did you say you might want to try?
Labeling that I and putting it outside of the original function, because essentially the integral of e to the x is just going to give you the same function, meaning that you're going to have to integrate by parts every single time going in the loop. So I believe if I wasn't mistaken, we said that we would subtract I.
Well, no, but be careful here. You have a good point, but be careful. You can only call it I. You can't call it I yet. You're right, though. It is I, though. It's the same original integral. But you may not be able to call it I just yet. You can't call it I yet because you don't have, you can say this is I, but this is not I. You see what I'm saying? This is in the middle of your integration by part procedure. So somebody made another recommendation. What would you do? You want to do integration by t sub? Is that the recommendation? Try t? You want to try t? All right, try t then. What happens by t sub? dt dx is going to be 1 over what? 2 squared root of x? Is that true? What does that mean about dx then? Dx will be 2 squared root of x. Well, solve for dx. So here's somebody's making a recommendation. They say, try to do this. So dx will be 2, it looks like there'll be a dt. Double check. Yeah. Okay. So then that v integral becomes the following. Okay? V is e to the t. What's the dx? 2 squared root of x dt. Is that true? Okay, but what do you guys know about t here? Isn't that t? So my v is 2 integral t e to the t dt. Is your v. So we haven't even integrated v yet. Is that true? All right. Now, here's what I want to remark. It might be good for you guys to know this. Memorize this integral. Get that in your memory. Wasn't that the first example we did? Isn't that t e to the t minus e to the t? Was that the first example? You guys know what I'm saying? Double check. Was that our very first example? I think that was. And is it t e to the t minus e to the t? Okay, and then that means since t is what? T is going to be, what is our t, square root of x? So this answer is the square root of x, e squared of x minus e squared of x plus c. Now that's only this what? This v here. Okay, so keep in mind, let's see if this got us anywhere. I'm just approaching it like a student doing all this work, which is what I'm saying you guys want to do. This is going to be, oh, what is this again? U, V. So we're going to take this u. This is my u here. Square root of x. They're going to write it. It helps me to write it down this way. uv minus integral what? V du. Okay? So over here, what was u? Square root of x? So this is square root of x. What's v? Square root of x, e squared of x minus e squared of x. That's my v. Minus now the integral of v. You say, what is the integral of v here? Square root of x, e squared of x minus e squared of x. And then I need my du. Say, well, what was du? This is my du up here, right? The whole reason you got this, so du would be 1 over 2 squared of x dx. Okay? So I need to multiply that du here. Yeah. What's that? Right here, v. Oh, you forgot the 2? Yeah. So let's double it, okay? Let's double that. And so what is v? Where is the v here? 2. So here you go. Okay? 2 times, 2 times. 2, 2. So get rid of this constant, get rid of that constant here. Okay? And this is what we called what again? V. And then, all right, so you got this minus 1/2 in here in green. Don't forget there's a 2, right? So I'm going to bring out that 2 here. So you got this here. Where is this here? Here's a 2. Here's a 2. Okay, minus the integral of what? That 2 constants here. So we're going to bring that 2 out. Okay. So let's double check here. This is in green. So this is going to be 2x e square root of x minus 2 square root of x e square root of x minus that 2. It's going to cancel here with this 2, right? So the 2's gone. And then you have minus what? Square root of x e square root of x minus, and we always need space. And that should be a du, right? So that's all in green, but we have to take 1/2 of all that. Is that right? So don't forget, this is just the green integral. So don't forget, you're going to bring this portion down here. Copy that, bring it down. And then it's minus 1/2 of all of this you guys see in green. So you say 2x e to the square root of x minus 2 square root of x e square root of x minus the integral square root of x e square root of x minus e squared of x du. Okay? And I'm going to call that integral I. So you have this I here all along. And, you know, doing this work, you say ex e squared of x, distribute that 1/2, and you get, say, minus x e squared of x plus, what is this? Square root of x e squared of x plus 1/2 the integral. Square root of x e squared of x minus e squared of x d. That should be a dx, right? Yeah. Okay, and then you say, hey, this is gone, and I'm just looking at this as a student, going through IBP, because that was what we talked about, and that's 1/2 the integral, what? Square root of x e squared of x dx minus 1/2 again, what? E what? Square root of x dx. Let me apologize to you guys. Yeah, that is I. And then what's the deal here? Isn't this the original problem again? Isn't that what? I? Is that true? So I have I equal to the square root of x e squared of x plus 1/2 square root of x e squared of x dx minus 1/2 I. And as you guys can see, it looks like we'll have 3/2 I. Is that true? Is the square root of x e squared of x plus 1/2 the integral square root of x e squared of x dx. Anyway, okay. And then you might say, but I have to integrate this. Now, here's my point to you guys. Okay? There is a slightly easier way to do this. You say, what do you mean? What was the original question? Because you still have to integrate this right here. We're not even done. Is that true? All right. What was the original question? Do you guys know? I think, wasn't that the original question? So here's my point to you as a student. You do this and you're going through the procedure. And you run into this issue and you say, why? It doesn't look like I'm getting anywhere. All right, you guys understand what I'm saying? It doesn't look like you're getting anywhere. What do you do? What do you guys think? Here's what you guys do. I'm going to say consider U sub. Do you guys know by U sub? If I let U be the square root of x. See how I kind of made a mistake earlier because I already did this in my head. Du dx, what's this? 1/2 square root of x. In U sub, I need to solve for dx. So dx is 2 square root of x du. Is that right? Double check. I think I'm okay. So now I get the integral e to the u, and what's dx? 2 square root of x what? Du? But what was the square root of x anyway? See this here? That's what? That's u. So double check. Does this mean I have 2 u e to the u du? Okay, what do you guys think? Is everything okay so far? Because I'm not awake and it's like, oh my gosh, all this drama moving us from one room to another and bringing all the gear. Didn't I bring out my constant here too? And then, what did I just get through saying to you guys, right? I said something like this. What did I say? That was our first example. What was this integral? u e to the u minus e to the u? Is that what it is? Do you guys remember that integral we did from example 1? That kind of integral shows up. And now, this really is 2 now, u e to the u minus e to the u, which gives you that 2u e to the u minus e to the u. You might say, is there a plus c? Well, maybe, but I don't think they gave it to us that way, right? It's not plus a constant anymore. What do you guys do? You had limits, okay? I thought we had limits. What were the original limits? 1 and 4. Good. So x is 1, x is 4 here. Okay, so x is 1. The lower limit is the square root of 1, which is 1. X is 4. The square root of 4 is 2. So my u is 1 and 2. So u here is what? 1 and then 2 here. So ladies and gentlemen, this is my antiderivative function, but it's in terms of u. So this would be f of 2 minus f of 1. And then that becomes 2 times 2 e squared minus e squared minus e squared minus 2 times 1 e to the first minus e to the first. Let me double check here, okay? 2 times 2, u is 2, e squared minus 2 times 1, e to the 1 minus e to the 1. Okay, looks like we're okay. I don't know, is it 1 and 4 or 1 and 2? Did I make a mistake? Right here. Okay. Do we have the wrong limits? What do you guys? Is it 1 and 4 or is it 1 and 2? Right. If they gave us lower limits here, right? X is 1, x is 4. This is in terms of x. Our limits are changed in terms of what? U. So u is 1, u is 2. Okay, so now we get 4 what? E squared minus 2e squared minus, it looks like it'll be, this is 2e. Is that 2e minus another 2e? Double check. Yeah. Okay, so it looks like this portion is 0, right? So what's your final answer? Is that 2e squared? I think we're okay with that. So, ladies and gentlemen, like I said, U sub, starting this question off, saved the day. Now, how did you earn that? Do you guys know? How do you earn that kind of thing? You have to go through this what? This pain is what I'm saying. And that's like, these are all the instructions I gave you guys last week. And this week or today, you have slightly kicked up questions where now you may have to start U sub to begin with, right? And that's what I'm saying. So you may have to start U sub to begin with. Another example of that is something like this. X to the 5th power e, x to the 2nd power what? Dx. Okay? So here's another example where you're going to have to do what to start this off? You're going to want to use what? U sub. Just to start this off. Okay? So just like the last one, you started off with U sub. This is why U sub was so important. This is why, like I said, if you looked at the different videos I did for U sub, those videos to review, over the years, this was always the case where students come into a Calculus 2 course And maybe they never even seen U sub before. And they go, Mr. Judge, I didn't see U sub. Last year, I had a class. They all came back from the pandemic. You want to know what they did? I might have told you guys. They never really took the class. They didn't take Calculus 1. They took Calculus 1, but they used an app to do all their work, even on their test. So they cheated through Calculus 1. They cheated through pre-calculus because it was in the pandemic. They never took trig, and they show up in Calculus 2. And then they're like, oh my God, I don't know what I'm doing. I have no idea. And there's a whole group of those students who go, Mr. Judge, we did this. What happens now? What do you think I told them? I said, go back and sit in these classes so you can learn how to do the work. So what's your major? I'm going to be an engineer. Like, you got to learn this stuff. You got to do the work. So, some of them were like freaked out because of it. But historically, you have had students who showed up without USUP. This is why I send you guys the video and stuff and said, hey, review your USUP. This is why I even came in years ago and recorded a video. So I think to just kind of illustrate here, like we did before, how are these questions similar? Right? Where did I do it here? You see this here? We're going to let that be U here, right? We're going to let this be what? U. And like I said the other day, these problems are specially chosen. Let me see if I double checked if I wrote it down correct. I hope I did. Anyway. So there you go, and you say, okay, what is this by USUB? Well, that means du dx is what? 2x. And then that means dx becomes du over what? 2x. So this is going to be, it's x to the fifth still, e to the u, and then you get du over this what? 2x. Okay, you guys okay with that? What do you think happens here now? Yeah, we get now, and I'm going to pull out the constant, 1/2. This is x to the fourth, e to the u du. So they pull out that constant here, okay? Now, here's another thing I want to remark here. You can't, don't think x to the fourth is a constant. I can't pull out x to the fourth, can I? Okay, you guys know what I'm saying? But go back here and remember, what was u? U was what? X squared. So what does that mean about this? That means u squared, is that right? That's the integral of what? U squared what? EU du. Okay, you guys okay with that? And then I'm going to say, now note maybe, this is where you use what? IBP. Okay? So here you're going to say, I want to use now IB what? P. What do you guys do to use integration by parts? Remember the idea we said? What is this? What's the theory behind this integration by parts? You want to break down the function that what? You're going to let u, and maybe I'm going to say this. I'm going to do this. I'm going to do a note here. You might be a little like me, where you get a little bit OCD. Here's my point. You remember integration by parts has a u of v minus integral v du, but you already have the u here? You guys know what I'm saying? We already have the u. I want to know what that integral is. I might just go back to this. And now use integration by parts, because you have a different u. You got to be very careful with not confusing your u's. Now I might say, see that here? There you go. This is going to be my u, and this is my dv. You say, why? because what we said, integration by parts was always letting u be the function that reduces the power. I called it breaking down when you differentiate. So you're going to say, I have to differentiate x squared. What's the power now? Isn't that power 1? That's my point. And you're going to have to do IBP twice because you're going to have to go through that, 2 times. And then here, the dv is e to the x dx. So now that means v is the integral of what? E to the x. Well, v is just e to the x. So integration by parts, though, is this is equal to uv minus integral v du. So what I'm saying is I solve for du, not dx. And now uv, you say, okay, this is x squared e to the x. uv minus integral v e to the x du is 2x d to the x. So by integration by parts, I broke this integral down because now, right in here, it's not x squared, it's now x. This is where you use the what? IBP again. So this is the essence of integration by parts. It's breaking down that function, reducing the power from x squared now to x, and now it's going to be gone. Okay, so here's going to be that u. So here's my u, and this whole thing is my dv. So now in gold or whatever color, u is x here. du is dx. Let's be careful. dv. Right? So dv is what? That's the e to the x dx, which means my v will be the integral of what? E to the x dx. V is e to the x. So uv minus integral v du. So x e to the x minus integral e to the x, and du is d to the x. And I know what this is. This is e to the x, okay? Or at this point, if you said, you know what, Mr. Judge, I already knew that, right? Remember I said to memorize that integral? Integral of x e to the x? Could you have gone in straight and said, I know this is x, what? E to the x minus e to the x? The answer is yes. So if you already remembered that particular integral, you could use it. Okay, you guys know what I'm saying? That happens with these questions. So all along in purple here now, you say, well, what did I just do, right? Well, this is x squared e to the x minus 2x e to the x minus 2 e to the x, right? Don't forget the constant here, like we did last time. We forgot our constant. Don't forget to distribute that. And that, ladies and gentlemen, is this integral. Okay, let me summarize it for you guys. Okay, what is this one? X squared e to the x. So here's what this is. X squared e to the x dx will be everything you see here. X squared e to the x minus 2x e to the x minus 2 e to the x. Yes, plus c. But this is not the final answer, right? So be careful, because you say, what do you mean? You didn't have to integrate. You had to integrate this. You had to integrate, 1/2 of that. So what do I mean by this, right? Don't forget. This integral, I'm going to change this in terms of u. Don't forget we have this constant 1/2 here. So this is in terms of u. We did it in terms of x. So that means 1/2 the integral of e to the what? Well, where was it? 1/2 the integral of, where is this here? U squared e to the u du is 1/2 of this. This is going to be x squared e to the x minus 2x e to the x minus 2 e to the x. So that's 1/2. Oops, let me not do this here. Let me go back to illustrate my point, okay? Let me do this. I change the variables. Change the variables back to what? To u. See that? Change it back to u. This is what I mean. The integral of u squared e to the u du is u squared e to the u minus 2u e to the u minus 2 e to the u. Yes, it'll be plus c. Okay? But don't forget, that was this integral right here. The integral of u squared e to the u. So 1/2 of that is 1/2 u squared e to the u minus 2u e to the u minus 2 e to the u. And some people, what they like to do, although you can't factor out that 2, this will be what? 1/2 u squared e to the u minus u e to the u minus e to the u. Some people like to factor out the e to the u. Okay, so they kind of have that u squared minus u minus 1. So they factored out e to the u. Let me double check. Did I make a mistake on that? I think I did. This is going to be what? 1/2. What's that? It's going to be just e to the u? Well, hold on. Let's see if we get this. Take e to the u 1/2. Okay. So here, right? You go back over here. What was u to begin with? What is u going to be? X squared. Is that true? This is x squared. So hold on. So remember, our u is, in fact, what? X squared. So final answer is e to the what? X squared. 1/2. What is, okay, I'll put the x squared minus what? X squared minus 1. So e to the x squared will be 1/2 x to the 4th minus x squared minus 1. So double check here. Okay, so this is what I want to remark about starting this off with u sub and how it makes it, believe it or not, it makes it a little bit easier. But be very careful because of the fact that u sub and integration by parts have the letter u in it, and you don't want to confuse your u's. That's why sometimes you start it off with t. Anyway.
So you've been doing the first step inside of the u, we use the t.
You could. I used to do that personally. I used to use t sub. But at that point, like I said, at that point for me, I was a student that did u sub all day long, and I didn't like integration by parts having the u. So I changed it to t sub. And you can change it to any letter. It's kind of like, for example, you know, I don't know, did we do this problem here? Do we integrate natural log? I know it's an example in the book. Did we do that one? Okay. So what was that integral? You guys remember the answer for that one? Isn't that x? Natural log x minus x plus c. Do you guys remember this? Okay. So what if they did this to you? Because if you look at your book, they might ask you to integrate now. Natural log may be what? 3x dx? Okay. So really, it's like, how would you go about it? It's really, you could do integration by parts from the beginning, but here's what I would say. We're going to call this a note here. So I would say use here u sub. Where what's u going to be? U is going to be what? 3x. And then that means du dx is 3, or it means that dx will be what? Du over 3? So that this integral really becomes now natural log u, and then that's du over what? 3. So you can pull out that constant. Okay? And because you already did before, here's kind of the idea. Well, two things to say. Logically, if you don't know this integral, and maybe you don't, but you remember, oh, we did that example in class. We had to use what? IBP. Well, use IBP. Okay, you guys see my point? Yes, I know it has the U again, but okay. And then you said, oh, I think I knew what that was. We already did that. That's why I gave you the note. It's what? U, natural log U minus U. And that's kind of the idea, but you have that factor of 1/3, okay? You guys see what I'm saying? So then that integral is 1/3 U ln U minus 1/3 U plus that C, but this was really a U sub question to begin with. This is why that U sub was so important. You know, this is why U sub. So U is 3x. So you say, what do I do with that? Well, you plug in that 3x here wherever there's U. And then that gives you now what? 1/3 times 3x, natural log 3x, 1/3 times 3x plus that c. So when we finish this off, it's x, natural log 3x minus x plus c. It looks like. Double check. Did we do this okay? Looks good to me. Anyway, so those are kind of some questions that they show you. Even for example, you know, if you said to me, what if they gave me something like this? E to the x sine what? 2x dx. Did they do that in the book? Did we do this integral? Which one did we do? Do you guys remember? Was it e to the x? How would you kind of handle that one? How about if we make it interesting? You say, what do you mean make it interesting? What if they gave you this? Right? E to the minus x sine 2x. That one is not so what, I would say. That one's not so interesting. That one's not so fun. What is that? What do I mean by this? If I can keep it, wow. Did the book give you something like this? I think so. What do you think you would have to do with this one? There's no U sub that you can do. I mean, yeah, I guess you can, but it might be, it's not as straightforward as a U sub. So I might say to you, you might have no choice but to do what? IBP. If they gave you, but they didn't, something like e to the 2x, sine 2x, then you could use u sub. You guys understand what I'm saying? Then you might say, oh, we're going to use a u sub here, where u is 2x. But they didn't give you that. What did they do? They did, you can kind of even do u sub, but it's still going to be the same kind of problem. When I started to write down is something like this. Could you use u sub here? You can, but you're going to have to do another version of u sub again. Anyway. So here you might have no choice but to use ibuprofen. Okay? This is what the other students used to call this, ibuprofen. U is what? E to the minus x. dv is sine of what? 2x dx. So this one, you're going to have no choice. You're going to go through this again, and you're going to find what? You're going to call this I. But, it's going to be something where you have to do a little bit of tediousness to get it out, right? So du dx, what's the derivative of e to the minus x? You guys know what that is? It's e to the minus x minus 1. Is that right? So du is minus e to the minus x dx. V is the integral of sine 2x dx, which means, we have to do a u sub there or a t sub. But if you're already good with that, what do you guys know? Isn't this going to be what? Derivative of cosine is minus sine, right? So that's minus cosine 2x. Don't forget, there's a 1/2 there. Yes, it's T sub. Yes, it's U sub, whatever you want to call it, right? So let's get rid of this because we don't have that. So what do you guys do? What's integration by parts, that song? uv minus integral v what? du. So uv here, you're going to get what? Minus 1/2 e to the minus x cosine 2x minus that integral of v, where v is minus 1/2 cosine 2x du is a minus e to the minus x dx. So what you're seeing here is 3 minus signs. So that's going to be a negative, right? Negative 1/2 integral e to the minus x. This is now cosine 2x. This isn't your I like before. I is e to the minus x sine. So what I'm saying is, yet again, to get I, you're going to have to use what? Integration by parts. This is not I. This here is I. It's e to the minus x sine 2x. So it's the same pattern like we did last time. It's just now you got to do integration by parts yet again. So now we say, okay, u is that e to the minus x, and dv would be that cosine 2x. Yes, u is not breaking down when you differentiate. And it didn't matter. If you said u is cosine, it's not breaking down either. So, but you might say, I think I kind of know what to do because I seen that last week. That's my point, that when you do some of these questions over and over again, you try them out and pull your hair out, you start to recognize it, and you want to use some of those facts and those ideas. That's how you do it. There's no, I know sometimes there's always that simple question, because you tell me what to do without really having to go through the trial and error process. It's like, not really. Nobody can. Yeah, nobody can do that. Yeah.
Why at this point we cannot say this one is I?
Because be careful. I is what? Sine. It looks like it, but it's not. The I is e to the minus x sine 2x dx. This here is cosine. So you got to be careful with that because it's cosine. But if you do IBP again, you're going to get the sine. Just like before. Just like the last one. Yeah, it's you have to, like I said, you have to go through that e to the x sine of an angle or e to the x cosine of an angle. You got to do it a few times and you go, oh, I see this is going to happen. And they like to throw those questions, but notice the author threw this in the book, e to the minus x cosine 2x, or a version of it. I believe so. So just it's the same exact process. And don't forget the dx. So, okay. du dx, again, is e to the minus x. Don't forget the chain part, which means du is minus e to the minus x dx. Don't forget chain, ladies and gentlemen. That's why chain rule is so important. The v now, I think of it this way. Derivative of sine is cosine, but it's a u sub. So this is going to be 1/2 what? Sine 2x for your v. Okay? This is why that u sub, those basics are so extremely important. And this is why I personally spent a lot of time on u sub and chain rule personally as a student. A lot of time. As you guys can see, it's needed. Like I did that in Calculus 1. A lot of time there. So, all right, what does this become? 1/2 e to the minus x sine 2x. Okay, that's my uv. Minus the integral of v. It's 1/2 sine 2x. What is du? Minus e minus x dx. And then that minus the minus makes this a what? That's a plus, and pull out the 1/2. So double check. Okay? Now remember, you got to be careful with all of this. Okay? Be careful. We're going to have to bring this portion down. Is that right? In fact, not just that, we're going to bring this portion down. Just be very careful. So, okay, that is here. Okay. All right, and then you say, what's the purple part is all of this here. This is all the purple. Yeah, there's a dx. So that's the purple part. And you say, okay, what is that? Double check, ladies and gentlemen. This is the part in purple here, right? So I'm going to put a box there. 1/2 e to the minus x sine 2x. And then that's plus 1/2 integral. And I really hate when I run out of that space. 1/2 integral e to the minus x sine 2x dx. Okay? So don't forget, this is I, and this whole thing is what? I. So that's helpful. So I is negative 1/2 e to the minus x cosine 2x minus 1/4 e to the minus x sine 2x, right? And then that's going to be minus another 1/4 times that I integral. So double check our algebra is okay. Because now, if I translate, move this to the other side, right? I add 1/4 I, that's going to be 5/4. Is that true? I get 5/4 times that I equals negative 1/2 e to the minus x cosine 2x minus 1/4 e e to the minus x sine 2x. I can solve for I. And I'll put it back as black color. I is going to be 4 what? Fifths, the reciprocal. Negative 1/2 e to the minus x cosine 2x minus 1/4. I think they're both negative. E to the minus x sine 2x. Okay. Sometimes people will factor out the e to the minus x. Anyway, I will be negative what? 4/10 e to the minus x cosine 2x minus 1/5 e to the minus x sine 2x. And 4/10, what does that reduce to? Is that 2/5? Is that true? Double check. And sometimes what people will do, they'll factor out, like, for example, negative 1/5 e to the minus x, and then they just have 2 cosine 2x plus sine 2x. You don't have to. Okay? You don't have to. Let me double check to see if my algebra is okay. Negative 1/2 e to the minus x. I had no sleep. All right. All of this without sleep, ladies and gentlemen, last night. Okay, no sleep for Mr. Judge, and so he's not exactly 100%, and we didn't get to some of the area and volume questions I kind of wanted to get to, so maybe you guys can look that over, but in my notes. But I hope you guys learned a few things, which is what? You do have to try some of these out on your own and cry, kick, and scream. Sometimes you have the U sub to start with, and if somebody says to you, can you tell me what to do without me having to think about doing anything? I wish if I could do that, I'd bottle it and sell it. I'd be richer than Bill Gates and Jeff Bezos together. Okay? And that, I would love to do that, but nobody can tell you. These are just the tips you can give somebody is, hey, remember some of those answers you got prior because they help you by integration by parts. They really are very helpful, some of those past integrals. Sometimes you start doing integration by parts, you're going to get to where it's so tedious that you don't make a lot of headway. It might even cancel out on you. And you go, oh my God, I have to do something different. And that's when you start to think, well, maybe I do U sub first. But you want to be able to do U sub, be a master of that U sub first. Okay, because that's kind of where, if you're weak with U sub, having you do U sub before integration by parts is kind of like, you got two problems now. Kind of having two bad legs. The U sub bad leg and then the integration by parts bad leg. It's going to be hard to run. You know what I mean? So anyway, take a look at those questions, and we're going to be back when? Here tomorrow in this room. Hopefully everything's fine. Okay? But, and hopefully you guys appreciated again doing some what? Doing some U substitution here. Where is it? All right, so take a look, ladies and gentlemen. See what you guys can do, and I'll see you guys when? Tomorrow.